So in this video, we're going to be introducing the concept of price elasticity. And we're going to be talking about the price elasticity of demand and the price elasticity of supply. So before introducing the concept of elasticity, I just want to draw an analogy, okay? An analogy with a concept that will be more familiar to all of us and which will actually help us down the road to actually understand how elasticity is calculated. Okay, so I'm going to write this very familiar ratio down. Kilometers per hour. Okay, so of course this is a measure of speed, or more specifically, a measure of velocity, right? And it tells you when the car, let's say, has been traveling for 1 hour, how many kilometers will it have covered? How many kilometers will it have traveled? Okay, now if the answer to this is 100, so we get 100 kilometers per hour, right? We say, okay, the car's traveling at 100 kilometers per hour, by which we mean if the car drives for 1 hour, it will have covered 100 kilometers, okay? So the reason I'm bringing this up is to point out the following fact, which you might have noticed before, you might not have, which is that this here is actually a division. Okay, you're dividing the number of kilometers by the number of hours. And by doing that, you're getting the answer to the question, how many kilometers did the car travel in 1 hour? Okay, so another way of putting this, which will be useful for our purposes, is how sensitive to a change in time is distance. Okay, now that might be a very strange way of asking this question, but it actually kind of makes sense, right? When time changes, quote unquote, right? So when the car has been traveling by 1 hour, right? So we're now 1 hour into the future, right? How sensitive was distance to that change? In other words, by how much has our distance changed? How far has the car traveled? That gives us the answer to, or that gives us the familiar concept of speed or velocity. Okay, so you're actually dividing the number of kilometers by the number of hours. Okay, I'm just trying to point out that sensitivity here. Okay, the idea of sensitivity is actually intimately connected with division. Okay, so the thing that is sensitive to the other thing is on the top of the division, right? It's in the numerator position, so that's kilometers, right? And the thing that kilometers is sensitive to is in the denominator position, right? So that actually brings us to elasticity. Okay, now elasticity, specifically, let's start with, well, okay, let's put it this way. Price elasticity of demand / supply is defined as sensitivity of quantity demanded in the case of price elasticity of demand, or quantity supplied in the case of price elasticity of supply, to a change in price. Okay, now how would we measure this, right? According to our definition. Well, again, we want to know how sensitive quantity demanded is to a change in price. So that would put change in price on the bottom, right? Again, in our first example, we had how sensitive to a change in time is distance, right? So distance is the thing that will go on the top, and time is the thing that would go on the bottom. So if we want to know how sensitive, say, quantity demanded is to a change in price, we would just divide quantity demanded by change in price, or rather maybe the change in quantity demanded by the change in price. Now, of course, you might be wondering, okay, well, this is not exactly the same as what we have above because we have this little delta symbol here, which represents change. But of course, kilometers per hour could just as easily be written as, right, delta kilometers divided by delta hours. This would be how far the car has traveled versus how much time has passed, right? So you would it actually is the same thing. We just don't write it that way. Okay. So delta QD over delta P. Now, in economics, this is not quite right. Why? Because in economics, when we talk about elasticity, we're not really interested in the amount that demand has changed relative to the amount that the price has changed by. What we're really interested in is percentages. So what we're interested in is, okay, when price increases by, say, 1%, by what percentage will quantity demanded have changed? So we're going to amend this formula slightly. We're just going to put a percentage symbol behind it. So this would be our price elasticity of demand, right, denoted by this letter eta. And this essentially answers the question, when price goes up by 1%, okay. Actually, let's make it a little more general than that. When price changes by 1%, by how much in percentage does quantity demanded change by? Right? That is what elasticity is essentially telling us. Okay? So essentially, by adding this percentage symbol, rather than asking, okay, when price changes, say, by $1, by how many units would quantity demanded change by? Rather than saying dollar, we're just saying, okay, when price changes by 1%, by what percentage does quantity demanded change by? Okay? It's a little change, right? But it's useful in economics. And it is what we're interested in. It is what elasticity, in fact, is. Now, of course, this is price elasticity of demand, right? But we also have price elasticity of supply, which is exactly the same thing, except we're interested in quantity supplied here. And, of course, price on the bottom. And this is usually denoted by eta S. Okay, so this up here is price elasticity of demand. This is price elasticity of supply. The difference between the two is just that over here we have quantity supplied, whereas over here we have quantity demanded. Okay. Now, of course, in the second case, what question would it be answering? Well, it would simply be answering the question, when price changes by 1%, by how much in percentage does quantity supplied change by? Okay, so that's price elasticity of demand and price elasticity of supply. Okay, now how do we calculate it? Well, this is where elasticity in economics is actually quite different, or is a little bit different. I shouldn't say quite different. It's a little bit different from the way you might be used to calculating percentages. Okay, so let's take just a very quick example. Okay, let's say that our price has gone from 10 to 15, and in response, our quantity demanded has gone from 100 to 50. Okay, pretty standard. Price has increased, quantity demanded has decreased in response. Okay, so let's think about how we would normally calculate the percentage change in price. Okay, just as a reminder, what we're interested in here is the price elasticity of demand, which is the percentage change in quantity demanded divided by a percentage change in price. Okay, now, how would we normally calculate our percentage change in quantity demanded? Well, what we would do is we would say, okay, price has gone from 100 to 50. Okay, so our initial amount is 100 and our final amount is 50. So what we would do is we would say, okay, that's a change of minus 50. Okay, so we would do 50 minus 100. And then, of course, you would have to divide that by the initial amount, which is 100. Okay, so by dividing this change, right, by our initial amount, you get the fraction of the initial amount represented by the change. And now to get it in percentage terms, you would just multiply that by 100. Okay? And then you would divide that by, you would do the same thing, except you would do this for price. So the final price is 15 and the initial price is 10. Okay, so that's a change of 5. So you do 15 minus 10, which is a change of 5, and then you would divide it by its initial amount, which is 10, multiply that by 100. Okay, so that's how you would normally do it. So let's just calculate this and see what we get. Okay, so what we would get here, so 50 minus 100, that's negative 50, right? Divided by 100, right? That would be negative 0.5. So you'd get negative 0.5 times 100 divided by, now 15 minus 10 is just 5, okay? And 5 divided by 10 is also 0.5. Now, did I make a mistake here? 15 minus 10, 15 minus 100. No mistake. Okay, no mistake. No, just checking. Okay, so this would give us, on the top, we would get negative 50%, right, divided by 50%, right, and this would just give us negative 1. Okay, and so our elasticity would be negative 1. Now, I am going to suggest that there is a problem with this. Okay, and the problem is the following. Now, this is not a mathematical problem, okay? This is actually mathematically correct. There's no problem with it in terms of math, but there's a problem with it in terms of economics, in terms of what we actually are trying to measure when we talk about price elasticity. So let's say that we were doing this the other way around. Okay, let's say that rather than talking about a price increase from 10 to 15, we were talking about a price decrease from 15 to 10. And rather than talking about a decrease in quantity demanded, right, we would be just talking about an increase in quantity demanded because price has gone down. Okay, so let's do this calculation now. So rather than 50 minus 100 over 100 on the top, we would be getting 100 minus 50 over 50, right? So in this case, we would be getting 100 minus 50 over 50 times 100 divided by, okay, now price is not going from 10 to 15. It's now going from 15 to 10, right? So we would get 10 minus 15 over 15 rather than 15 minus 10 over 10. So 10 minus 15 over 15 times 100. So what do we get here? All right, so 100 minus 50 is 50. 50 over 50 is, of course, just 1, right? So we would get 1 times 100 on the top. And in the bottom, right, 10 minus 15 is negative 5. And negative 5 divided by 15 is negative 0.33 approximately times 100. So essentially we would get 100% on the top, and we would get a negative 33% on the bottom. And we would essentially get, we would get approximately 3 here, right? It would be 3.03, but we could write this as 3 approximately. Okay. Now, what do you notice? Of course, these two numbers are not equal. Okay, so depending on the direction of travel here, okay, we actually get a different elasticity. Now, economists don't like that. We don't want to get a different elasticity depending on our direction of travel. Okay, so this way of doing it over here is actually wrong in economics terms. Okay, we do not want to be getting different results depending on our direction of travel. What we want is we want to be getting the exact same number regardless of whether we're talking about a decrease in price resulting in an increase in quantity demanded, or whether we're talking about an increase in price resulting in a decrease in quantity demanded. Okay, so how do we solve this problem? Well, we solve this problem in the following way. We solve this problem by taking averages. All right, so price elasticity of demand is equal to percentage change in quantity demanded divided by percentage change in price. But we're going to take the percentage change in quantity demanded relative to the average quantity. What do I mean by that? So previously we had quantity demanded 2 minus quantity demanded 1, but then we divided that by the initial quantity, which was quantity demanded 1. But in this case, we're not going to do that. What we're going to do is we're going to take the average of quantity demanded 1 and 2. So quantity demanded 1 plus quantity demanded 2 divided by 2. That's the average. And we're going to do the same thing on the bottom. We're going to take price 2 minus price 1 divided by the average price, which is P1 plus P2 divided by 2. Okay? And then, of course, for price elasticity of supply, this would be our percentage change in quantity supplied divided by our percentage change in price, which is going to be equal to the exact same thing as we have above, except it's going to be quantity supplied 2 minus quantity supplied 1 divided by the average of the 2. Whole thing divided by change in price, right? Taking the average as above. Okay, now, why does this make a difference? Well, let's just continue using our example that we had here above, right? So when price increases from 10 to 15, quantity demanded decreases from 10 to 50, and vice versa. When we go from 10 to 15 in terms of price, we go from 50 to 100 in terms of quantity demanded. Now, let's actually do those calculations taking averages. Okay, so, and I should also mention, because this is pretty important, actually, yeah, this is quite important. When it comes to elasticity, we always want to get a positive number. Okay, so to get a positive number, you just take the absolute value of these calculations. Okay. And some of you might have noticed that I'm not including the times 100 on the top and on the bottom. And that's actually on purpose, right? If I included times 100 over here, times 100 over here, they would just cancel out, right? So we don't actually need to do that. Okay. Now we can get to our calculations. So, let's take the first case where price goes from 10 to 15, and in response, quantity demanded goes from 100 to 50. Okay, first of all, let's just calculate these averages to begin with. Okay, what's the average of 10 and 15? So 10 plus 15 divided by 2. This is just 25 divided by 2, so that's 12.5. And 100 plus 50 divided by 2. This is 150 divided by 2. So that's 75. Okay? Now, Q2 minus Q1. Okay, so QD2, sorry, minus QD1. So QD2 would be 50, right? And QD1 would be 100. So 50 minus 100 is negative 50. The average of the two Q's is 5. And on the bottom, P2, which is 15, minus P1, which is 10, will give us 5. And the average of the two prices is 12.5. Okay, so let's, and of course, cannot forget the absolute values. So, negative 50 divided by 75 is approximately negative 0.67. And 5 divided by 12.5 is 0.4. Okay. And now taking absolute values, you could just get rid of the negative sign. So 0.67 divided by 0.4 is 1.675. Okay. Now, notice that if we did this the other way around, okay, if we went from 15 to 10, and therefore from 50 to 100, what would we get on the top up here? Instead of negative 50, we would just get 50, right? Because 100 minus 50 is 50. So you can get rid of that. So it's just 50. Now, because we're taking averages, this bottom part here, this denominator doesn't change. It's 75, right? Now, what would we get here? What would we get here? Well, you'd be doing P2 minus P1, right? So P2 in this case would be 10, and P1 would be 15. So 10 minus 15 is negative 5. So you'd add a negative over here. And the bottom, right, would just be 12.5 because we're taking averages. So what would we get here? We would get positive, we'd be getting positive 0.67 divided by negative 0.4. But because we're taking absolute values, we would still get the same result, 1.675. Okay, so by taking averages and by taking absolute values, we ensure that no matter which direction we're moving in, we always get the same result. Okay, so that's why we take the absolute values. That's why we take averages, right? And of course, the same exact thing, of course, applies to quantity supplied, right? If we're talking about price elasticity of supply. Okay, so this is our final formula. And finally, what is our interpretation of this 1.65? What this means is that when price goes up by 1%, okay, quantity demanded goes down by 1.675%. Okay, and we're going to talk about the significance of that a little bit more in our next video. Okay, so as usual, if you found this video useful, please like the video, subscribe to the channel, leave a helpful comment down below if you have suggestions for further videos, or if you have any questions on videos that have already been uploaded. And I will see you in next video.